Okay, so I'm going to jump over here to number 10. And let's see. So our parameters are when x is less than or equal to 3, when x is between 3 and 5, or when x is greater than or equal to 5. So let's set up some of our x values then according to this. Make a nice little table. So let's start with, well, let's start with 0, 1, 2, 3, 4, 5, and 6, because that should help us with all these. So when x is less than or equal to 3, 0 is, so that's going to give us our positive 7. There's our y-intercept. 6, 7. When x is 1, positive 4. Okay. X is 2. Then when x is 2 is negative 6 plus 7 is 1. We're basically going down 3 and over 1. However, this keeps up until we hit x is less than or equal to 3. So now we have x is 1, 2, 3. That's as far as we can go. And it is equal to 3, so we're going to make sure that dot is colored in solid. And there goes our function. Now, what if x is 4? Well, when x is 4, it's just x. So 4 is 4. 5 is 5. But what about, these aren't colored in. At least that one's not colored in. That one is not included. And neither is 3. We still have to account for all the values, though, that are between 3 and 5. Now, what does that mean? Let's focus on that for just a moment. So basically at 3.1, even at 3.01, like those x's are between 3 and 5 and are included. It's just x is 3 and x is 5 are not included. So because it's really hard to show all the little values between 3 and 4 and between 4 and 5 that are included without using circles, you have to at least acknowledge 3 and acknowledge 5 at the ends. Okay? But we can't include them, so that's why they're open circles. So now, once x is greater than or equal to 5, it's going to be negative 1 as a y. So we're going to just find x is 5. We're going to find negative 1 here, include it, and it's just now a line forever going that way. So the domain of this function is going to be rather interesting. So the domain are all the x values that produce a y value. And basically all x values will, because the only places that it might not would be 3 and 5, but they're included by the other two functions. So it's still all real numbers, but it's the y that gets interesting, because there are no y outputs below negative 2. So y is going to be greater than or equal to negative 2, but never less than or equal to negative 2.